Let's go to the previous videos now, and sorry, previous codes, where I have these code for job submission. These two are the codes I'm going to use. So I will copy them and then go to lab 4. Right, this is now lab 4. Let me show you the code here. It's nothing complex, more complex than just only a few rules that I have set for the ABAQUS file. So it's not something like a difficult code to consider. You can for your help you can write it here. If I show you the line number, it's available on my GitHub repository. All right. So let's just go to another code which is for the monitoring of job, and if you want to copy this code, I will switch on the line number here, and you can pause the video and look at the code here, which is a good tool to consider. So these two codes are very important. If, for example, if you don't want to work on ABAQUS and you prepared your input file, right? So I can do it in this way. Let's say I want to do changes in this code, and let's say you are doing a parametric study, and you want to check the effect of elasticity, right? So you can change the values, take the copies from the input files, and keep all the input files in the same folder, and then it will work for you. So these informations are appearing here because I use my Python tool to generate the Prani series coefficients. Make sure it has some issue, and it is because of the addition. We were facing some problems in the submission of Unity for normalization. So now it's okay. We removed some of the point from there, and we got what we were looking for. So these are the material inputs that I have already used there. So what you will do, first you will try to double click on this code, monitor job, so it will give you an option that it's looking for the directory scanning. And before that, let me close the ABAQUS, because I want to show you that you can do this using Python. And in the meanwhile, then I will come back to the original this one ODB file and work on the other Python codes. So let's go to the submit job, and for job submission I will just double click on it and the job will be submitted already. So when the job is submitted, then you can look at here. As soon as the job is submitted and the solver start simulating, then we will read the status of the ABAQUS file from here. So it's a very good thing to consider. Even you can close, you can see here that you can close your ABAQUS file and you don't need to work on it. So now just you need to focus at this region. When the job is started, you will be able to see that it's giving you live updates of your file. So it's a good thing to work with automations and make your life easier with such kind of stuff. So ABAQUS is not open, and it's only calling the ABAQUS kernel in the backend with bash and or another word in command prompt, and then it's giving me the status that the job is working. The only thing you should be careful about it, you should first remove all the warnings, and just like the way I did, and also all the errors from your file. So once you completed your pre-processing and troubleshooting and everything is fine, then your input file that you are using is ready for parametric analysis. And the input file, it's already present here, and I'm getting updates on my code here right now. And I can see here that my time period was 1 for this job, and it is a very high speed simulation, right? A very high speed. It's not a realistic one. I just demonstrated the methodology here, but still I'm able to see that the input file that is present here, it's properly working, and I have no issue with my ABAQUS. And when the job is completed, it is giving me a status that the job is completed. So sometime you will have plenty of files, not a single file, you will have plenty of files. So for that you need the batch submit file, which is available on my GitHub repository. All you need to do is just to take copies from the input files right here, and when you do all changes, keep all the input file in a single folder, and then click on that batch job submit folder, which I already have discussed in the previous videos, and it will help you in your simulation. So this was for the file that I discussed, and now I have so these post-processing techniques, visualization, and this section is remaining, and then for the scripting and batch submission, this already discussed here, right? Before proceeding further, let me mention that there is a good thing of future trend in ABAQUS. It can be combined with machine learning, and we already have done some work on it for soil structure instruction in machine learning. So it's a trend right now, and you should study Burmester theory and do some kind of automation, and then you can prepare your own machine learning model from your results dynamically. So which is a complete new folder, a new topic. And just in case if you have watched this full course, your next step is to model a realistic model for the pavement engineering and practice all the theories that we discussed here, and consider searching them by yourself. So if you have purchased this course, then these are the bonus material you should get. All the input files that we have considered, and those input files, as well as the all the folders that we have already generated here. So these folders are visible in front of you, and you will get all these folders. Let's close it. And also one thing more, if you have purchased this course, you will get lifetime support on my WhatsApp number, which is given here. So this concludes the full course up to this lecture, and I'm stopping recording further modules on this lecture. So let's go back to the visualization module, and let's do this with ABAQUS viewer only. And I have a code here. I think I have mentioned that for active routing, but let me just create another folder, call it Python code for visualization of routing profile, right? And here if I have already included that code, then let's check what is going on here. So I will take this code required in the next let's just do it here. I will try my best to just copy it here because the code is already with me, so I don't want to spare some time on it. I will copy that code from other folder, and but before that, let's go to open the ODB file that we already did with Python, and let's go to option common and change scale factor to 1, and then click on OK. So we got this, and here let's go back to the lectures, and let's see. Let's take those codes here which we discussed previously for the active routing profile. So one code is for active routing profile, another one is for, I think, amplitude. So the amplitude, that's already done. We already have discussed this, and I already demonstrated in the previous video how to use this code. While this code, I will take this code, I will copy it, and then in the Python codes for visualization of the routing profile, I will take this code, I will copy it, and I will rename it with visualize routing profile, and I will just edit it with IDLE, right? Because this is the most simple thing I can use. Although sometime we need Visual Studio, I'm not using PyCharms and other modules, but that's fine. You can just keep it here. So if we look at the code, we need the results from the ABAQUS environment here. So the results we need are to be extracted at any point of interest. So let's go to ODB field output request data, and in the ODB field output request data, integration point is okay, but we are looking for routing profile, which is actually a unique nodal data, and I will take this node and then plot it here. So I got this data. Let's go to visualization tool and Excel utilities. So from the current profile, I will apply to just export this using the options available here. Other than that, I think I have covered everything. Still, if there is something missing, we can kind of discuss them as well. So let's just look at the profile here. We got the profile here, and I mentioned that the last routing should be more as compared to what we are seeing here. So minor changes for active and non-active routing data we are observing here, but it's a very smaller amount of routing. So let's just go to save this folder in the directory where we are working, and that directory is actually in D directory, and we are working with the visualization of these results, how to Python code for visualization of routing profile. And if I notice, I need the name of this sheet to be routing depth here. If you have any other name to keep for this file, you can use that name here. Other than that, we have some instructions here that the Excel sheet should contain 3 cycles. right? Look at here. So we did this by exporting it from ABAQUS. It should be in current directory, so it's already in current directory. The Excel sheet should contain 3 columns: column A for cycle numbers, column B for ABAQUS step time, and column C for routing depth. So we need to do this right now. So let's go to insert, right? And we have 0, 0.1, right? So we have 10 repetition, I think so. So 0, right, and 0.1, and let's do this. So let's yeah, so we got 10 cycles here, and we need to rename them with each pattern that we are following here in our code. So the first one is cycle numbers. So let's copy this from here and paste it here with the cycle numbers, right? And the second column name should be step time, which we will get from this. And the third one is actually routing depth. So the routing depth, ABAQUS will classify, Python will classify the active routing and non-active routing for us. So let's just close it, and by active routing I mean the routing which is actually obtained by only working with the load cycle, and non-routing or non-active is actually the routing which we are getting in the permanent position after the removal of the load. So let's just run this code. Let's see if we are okay with it, and if we are facing some problem, we can change them. So let's look at here and just wait for our code, that what it is going to do. I have mentioned this code. The reason why I am doing so much short narrations on these code is because I have explained them in detail in my previous videos on this topic. So I'm not spending too much time on it. I'm just waiting for it so that it calculates the local maxima and local minima. Maybe the results will be okay, or maybe the results will be not. The reason is we considered very small number of loading amplitudes. So for good visualization, we need some sort of large number of cycles, such as 100 cycles, not 100 passes. And for 100 passes, we will get 10 cycles, right? For 1000 passes, we will get 100 cycles, and so on. So passes is different and cycle is different here, and we should divide them, and I demonstrated them as well using the same thing that I mentioned here. So for the consideration of all these steps that I mentioned, we should be very careful about the procedure we are adopting here. So I got the profile here. The profile which I obtained here is not very satisfactory, and the reason is we have a very smaller amount of cycles, but we see the routing depth increased strength here. So it is for the loading, and for unloading it is very smaller value. So it's very smaller value. And in the similar pattern, you will observe the trend in your data, and you can also observe the pattern in the profile here as well. So this is kind of a practical project that you can visualize in your simulation, and you can get results as per your choice in your simulation. So I am going to close discussion on this course, and for further improvement in the course, maybe I will include further project as a bonus files to discuss and give my opinions on the flexible pavements and other type of pavements. Anyhow, this is the official statement that this course is completed at this video. Thank you so much for purchasing the course. Have a good day.